Hello students of Year 11 General Maths and welcome to exercise 4F, the slope-intercept form of a straight line. Now this is actually a revisit of a topic that you would have covered in Year 9 and Year 10 Maths, but I'd just like to remind everyone that just because you've seen a topic before, doesn't mean that you've mastered it. It doesn't even actually mean that you've learnt it. It just means that you've seen it before. So please take a chance to use this lesson and the exercise questions as time to really consolidate and really master this content, even if you've seen it before. Alrighty, now let's just remind ourselves the slope-intercept form of a straight line, it takes the form of y equals mx plus c. Now that just looks like a bunch of letters right now. Let's just remind ourselves m is the gradient or slope of the straight line in question. And c is its y-intercept. Okay, and the y-intercept is where it cuts the y-axis, where it intersects the y-axis. Now, y and x, they are both variables which represent the x-axis and the y-axis. Now, the way a function or an equation works like this is I can plug in an x value by substituting it in where x is, and whatever answer I get when I multiply it by m and add c onto it, that's the corresponding y value. So if I put in x equals 1 and I got y equals 2 out of that, that would mean a point 1, 2, where x is the 1 and y is the 2, exists on the line that I've drawn. Let's keep moving. So here's an example of the slope-intercept form in action. So this equation here says y equals 3x plus 1. So using what we just learned, the gradient, m, is equal to 3, and the y-intercept is equal to 1. Now, we would only need those two pieces of information in order to draw the graph. So if we take a look over here, it's already been drawn for us, and let's just validate that the information is correct. So we saw that the y-intercept is equal to 1, and we can see on the graph here that that's been marked in. The y-intercept is equal to 1. Now we can also see that the gradient was marked as 3. So we can check that as well because we have 2 points here. We've got point 2 and point 1. So all we need to do is to check our gradient is do a gradient calculation, and I'll do it up here. So m is equal to rise over run. Okay, well, you may have also seen this. M is equal to, y2 take y1 over x2 take x1. Use whichever version of this you're comfortable with. The one on the right here, what it means by y2, y1, x2, x1. Y2 and x2, they refer to the x and y values of the second point, and y1 and x1, they refer to the y and x values of the first point. It doesn't actually matter which point you choose to be the first point and which point you choose to be the second one. It just matters that you keep it consistent. So I'm going to use the rise over run version just because I think that is simple enough for us to all understand, and it works every time for me. So the rise in this graph here, well, it starts at 0, 1, with 1 being its y-axis value, and it rises up to 7. So it rises by 6. And the run is, well, it starts at 0 in the x-axis, and it runs to the right up to x is equal to 2. So it runs a value of 2. So 6 divided by 2 is 3. And we'll just do it over here just to satisfy ourselves. We'll do this calculation as well. So y2 refers to the y value of the second point, and here we can see that's 7. And the y value of the first point is 1. The x value of the second point is 2, and the x value of the first point is 0. So that's equal to 7 take 1 on the top, which is 6, over 2 take 0 on the bottom, which is 2, and that's also 3. So both ways gave me that the gradient was 3. So let's think about now why we would use the slope-intercept form of a straight line, or why would we look at linear modeling in general. And the reason is we can use straight lines or straight line equations to model real life situations. This includes any situation with constant growth or constant decay. So some useful examples for us are simple interest. Simple interest represents constant growth. We grow by the same amount every time period. Filling or emptying a container at a constant rate. So as long as the liquid entering the container is entering at a constant rate, so the same amount of liquid enters per minute, or the same amount of liquid leaves per minute, we can model with a linear equation. If you save money at a constant rate, so if you put away $50 a week, for example, every single week, a linear equation could represent that. And therefore, you could work out after 53 weeks, how much money do I have? Paying off a debt which doesn't accrue interest, it could also be modeled by a linear equation if I pay off a constant amount every time. And things like taxi and Uber fares, they can also be modeled with linear equations because they have a base rate, which represents the y-intercept, and then a increasing amount depending on the time taken or the distance driven, which represents the gradient. Now, there's four important processes that we need to look at involving the slope-intercept form, and they are these. The first one is stating the slope and intercept from an equation. So we can take an equation, and then we can say, what is the slope and what is the intercept? That's quite easy, and we'll take a look at some more examples. 2 is writing an equation when we're given the slope and intercept. So we could say m is equal to 2 and c is equal to 3. What's the equation of this straight line? That's also quite easy, but we'll look at some examples there. The third thing we can do, which is a little bit more complicated, is sketching a graph from the slope-intercept form of a line. So we're sketching graphs. And then the fourth important process we can look at is finding the slope-intercept form of an equation from its graph. But that is actually left till exercise 4G, so we won't be looking at that in this video. So let's take a look at that first example, which was stating the slope and intercept from an equation. So I've got 4 different equations here. I might only do 2 or 3 of them, we'll see. So let's do A first of all. Y is equal to 9x take 6. And my goal for this question is to just write down the slope and y-intercept of each of these. And I'm going to be using the letters M and C to represent those, and so should you in your work. So in this first one here, m is equal to 9 because the coefficient of x is 9. The letter in front of x is 9. So that means the slope is 9. Its gradient is 9. And c is equal to negative 6 here because I've got 6 here, but it's negative. So it's negative 6 in this equation for the y-intercept. Alrighty, let's do all these because they're quite quick. So b is y is equal to negative 5x plus 10. So my coefficient of x is not 5, but negative 5, because there is a negative sign in front of that. My y-intercept is 10, so c is equal to 10. Sorry, my constant term is 10. So my y value is 10, my y-intercept is 10. C says y is equal to negative 2x. Now here, my gradient, my m is clearly equal to negative 2, but there's nothing else in this equation. So really what that is like is it's like saying plus 0. So therefore I can say my y-intercept is equal to 0 because the constant term on the end is 0. And we'll do d just because we've got time. So y take 4x equals 5. And it's good that we did this one actually because it's a bit different to the others. So that I can say the y-intercept and slope of this line, I first need to move it into slope and intercept form because all of the other ones, they had y equals already. And as we saw before, the slope-intercept form, it says y equals mx plus c. So I need to rearrange this equation here in D to say y equals. So the thing that's stopping me from saying that right now is the minus 4x. So let's add 4x to both sides. Okay, so doing that on the left, I've got minus 4x plus 4x. So they cancel quite nicely, just like I wanted. And then on my right side, I'm left with 5 plus 4x. Now those aren't those aren't like terms, so I can't actually make them interact with each other. But let's just rearrange this so that my x term is first. So now it's y equals 4x plus 5. Alrighty, clearly now I can see that m is equal to 4 and c, my y-intercept, is equal to 5. So those are a few examples. They should definitely help you do your textbook questions which are related. Now here I'm writing an equation when given the slope and the intercept. So now I'll just do a and c. So slope is equal to 6, so m equals 6, and y-intercept is 9, so c equals 9. All right, I just need to remind myself it's y equals mx plus c. So now let's just substitute those two values in. So that means y is equal to 6x plus 9. I replace my m with 6 and my c with 9. Let's do c now. It says m is equal to 2 and c is equal to negative 3. Just reminding ourselves the general form is y equals mx plus c. So let's replace m with 2, so 2x, and we'll replace c with negative 3 now. So it's plus negative 3, which I can also rewrite as 2x minus 3. Cool. Also quite easy. Let's take a look now at the third important process we talked about before, and that was sketching a graph from the slope-intercept form. Now we just need to remember a few things here. And the first of those things is when we sketch a straight line, only 2 points on the line are required. So what that means is we just need to know 2 of the points that exist on the line, and then we can draw that line. That's because if I've got a point over here and a point here, the line that joins them is the only line that could ever join them, the only straight line that could ever join them. So once I've got the 2 points, I simply join them with a straight line and then continue it on. And then I've got the exact line that is described by the equation. Now, let's also remind ourselves that when we're in slope-intercept form, the y-intercept is immediately available to us because of the c value. So whatever c is equal to, that gives us a point straight away because we can draw in the y-intercept. So this can always be used as the first of those 2 points we need. Then the next thing we need to remember is that a second point can always be generated if we substitute a value in for x into the equation. So let's take a look at an example.